In Chapter 8.2, we'll continue to solve problems with permutations, but now we'll have added restrictions. Let's start with warm-up number 1. Here we are told of a family of 4 consisting of Mom, Dad, Becky, and Sandra. And they'll be lining up in a single row for a family photo. Now, the story says that Dad likes to challenge his children to determine how many arrangements there are of the family in a line in each case. So the first case is simply saying, determine the number of ways the family members can be arranged in a single line. So no special restrictions here. Well, if we have 4 family members, then of course we will have 4 positions in which to place them. We've been through this before. When we're arranging all the elements of the set, we have the number of elements as options in the first place. So we had 4 people, so 4 options. And then we decrease by 1 in each subsequent position. This is the same as simply saying 4 factorial, which is the number of ways to arrange 4 items in a set, and that is equal to 24. In part 2, we change this a little bit. We say, determine the number of ways the family members can be arranged if Mom must be on the far left. Well, at this point, we'll probably rely mostly on the fundamental accounting principle because it allows us to annotate and make really obvious what our restrictions are. So in this case, our main restriction is that Mom must be in this first position. Well, in this story, we have only one Mom. So that is the number of options we have for the first position. After that, there are no restrictions on who can be placed in each of the next positions. So in the second position, it could be Dad, Becky, or Sandra. That's 3 options. And then in the next position, of course, we decrease to 2 and then 1 because we've already placed some of the people. So with the simple restriction that Mom has to be on the left, we've gone down from 24 permutations to only 6. 1 times 3 times 2 times 1. 6. Let's make this a bit more complicated now. The photographer suggests that they take a few photos where Mom and Dad are standing together. Now in this first part, it specifies that Mom will be on the left and Dad will be on the right. Okay, so Dad wants to know how many ways can we do this. Sandra, one of the daughters, who studies grade 12 math and loves logic problems, asserts that since they, Mom and Dad, are side by side in each photograph, they can be counted as one person. And this is a strategy we'll use when determining the permutations where we have objects that are kept together in an arrangement. We're going to consider Mom and Dad here to be one object. And the reason for that is when we place Mom, we've decidedly placed Dad in the next position. So it's kind of just one decision. But there is another part to this, and we'll explore that as we look at the difference between case 3 and case 4. So in case 3, we have Mom, Dad, Becky, and Sandra, but Mom and Dad are considered together as one item because they are placed together. This means that we really only have 1, 2, 3 placements to make, or more simply, we have 3 objects to arrange, so 3 factorial arrangements of them. Because this question specifies that Mom is on the left and Dad is on the right, there's only one way to arrange them within their group. So 3 factorial times that one option, doesn't really need to be written, is simply 3 factorial or 6. So there are 6 arrangements here. However, in case 4, we still have Mom and Dad together, but this time it says that they could be on either side of one another. So what does this change? Well, this means we have Mom, Dad, Becky, and Sandra, and we have Mom and Dad counted as one object. So again, we have 3 factorial arrangements because we have 1, 2, 3 elements to arrange. However, within this grouping of Mom and Dad right here, we could be Mom then Dad or Dad then Mom. So that's 2 arrangements, but we're going to call it 2 factorial arrangements. And the reason for that is, even though 2 factorial is 2, if we had 3 elements in that together set, you would see that there are 3 factorial or 6 arrangements of this. So the rule for this is, as we put things together, we count the togethered objects as 1, but we count the number of objects in there to determine how many arrangements there are within that group. So 3 factorial makes 6, and 2 factorial makes 2, so 6 times 2 makes 12. There are 12 permutations in which Mom and Dad are together where they can be on either side of one another.